Welcome back to Don the Developer podcast, where we help aspiring web developers get jobs and junior developers grow. In this episode, we brought back a third person to try to attempt to get to the second problem of this FAANG level mock interview. And he did. Before we start this video, I just want to say thanks so much to Formation.dev for sponsoring this video. If you are a junior to mid-level engineer who wants to land a job at a FAANG level company, their engineering fellowship is made for you. Formation.dev is a fellowship program where their mission is to help software engineers from non-traditional backgrounds break into top-tier companies such as Google, Meta, and Microsoft. Formation.dev has undisputedly the top team of engineers from Facebook and Nextdoor who interviewed thousands of candidates and trained hundreds of interviewers during their tenure. This insight is how Formation created a better and more effective way to prepare engineers for the FAANG level hiring bar. On average, Formation.dev fellows increase their total compensation by over $80K after completing the fellowship. You can apply for free on their website, Formation.dev, and whether or not you are accepted into the program, you will get invaluable career advice from their assessment and a free prep guide that's a really helpful resource for your FAANG level interviews. Also, check out their YouTube channel for technical interview tips and interviews with Formation.dev mentors. All right, I know you're probably ready to get into this. So the interviewer, Daniel, he's actually head of instruction at Formation. He was an engineer at Facebook and Microsoft for almost 20 years, where he conducted hundreds of interviews, and he even created training materials for the interviewers. I think he's perfect for this, and I actually asked Daniel to help me find someone that would find the first problem to be pretty easy, but would find the second problem to be a little bit more challenging. And so Daniel actually found a fellow at Formation who's a perfect skill level with what we were looking for. And as far as I know, Brian, who's the candidate for this, he actually was not aware of the problem whatsoever. So this is fresh for him. All right, let's jump into this. Enjoy.
All right. Well, Brian, nice to meet you. Thanks for taking the time to talk to us this morning, taking time out of your busy schedule to work on some problems. I hope this is fun. I always have fun with these problems. I hope you do too. A little bit more about me, just so you know who you're talking to. You can ask kind of more intelligent questions. I've been a software engineer at Microsoft for 11 years and then Facebook for 8. Now working at Formation Labs as an instruction engineer. So teaching software engineers. It's been a lot of fun. Do you want to say a little bit about who you are, where you come from, and then we'll dive into some code?
Sure, yeah. Nice to meet you, Daniel. So I'm a software engineer, mostly with React, but just fun in general. I've had an internship. I'm currently a fellow at Formation. Yeah, it's looking for my first time full-time job, so I'm happy to interview with you today.
Yeah, awesome. So I'm going to send you a CoderPad link. We'll open that up. There's a problem already in there. I have arbitrarily picked JavaScript. If you want to choose something else, you're welcome to switch the language. I don't actually care what language we do this in, so whatever you're most comfortable with, do feel free to change it, and I'll roll with that. If you need anything, if you need any tutorial about how CoderPad works, feel free to ask. I know all these tools function a little bit differently, so just let me know if you need a moment to play with the CoderPad also, or need any pointers there.
Yeah, looks good to me. I do code in JavaScript, so this is good.
Okay, great. Yeah, give it a read, and then please ask any questions.
Okay. Okay, so I'm determining a point value possible for a word. Just to understand it correctly, it looks like there's only one possible value for this. So you have C, which has a definite value, A, which is a definite value, and T.
Right. And so in that case, it's just the sum of those values. Those are the points you can score given that input. Yeah, but the second input's a little different.
Right. So this one, you're missing C in the tiles. So you can only score up A, and you can score up D.
Right.
So
right, and you'll use the underscore to stand in for the C. So you can still make the word, you just can't score all the points.
I see. So is each tile reusable? Like if I had CAAT?
Yeah, good question. No, so each tile is a consumable. So you can use it once and then it's gone. So if the word is aardvark and you need 2 A's, but you only have 1, you can't make aardvark.
Okay. And so will I ever be given like duplicate tiles then? So like 2 A's, for example?
Yeah, you could be given 2 A's.
Okay.
Yeah, I mean, if you've ever played Scrabble, this is actually, the point values are actually exactly Scrabble. And I forget how many A's are in the game, but you could potentially have a full tray of A's, and that many words you can make with that. We're not actually going to worry about the limits and the maximum number of, say, A's or T's or whatever you can have. We'll just say like, hey, this is what you actually have, and can you make these words?
Okay. So to first kind of look at it non-codey, but just assuming, I guess, I would want to know which letters in my word I can actually sum up. And so to do that, I can look at my tiles. Since I can have like 2 A's, I want to know that, like if I had this, CAT, I could sum up A, but only 1 A. So it's also important for me to know the frequency of tiles, essentially.
In your, the frequency of letters, or frequency of tiles.
Right. Okay. And then, so once I know the tiles and frequency of tiles, I can basically just run through my word and sum that up.
If you have the tiles available.
Right. Okay. And let me think real quick. So the underscore is the only thing that might be a little weird. Okay, the underscore represents a point tile that can stand for any letter.
And it's consumable just like any other character. So let's, like once you've used it, because you say didn't have a C, now you can't use it again. But you might have 2 underscores, right? Just like you might have 2 A's or 2 T's or whatever, you might have 2 underscores.
Will I ever get a word where I actually don't have enough tiles to make it?
Oh, yeah, good question. Sure. In that case, score is 0. You can't make the word.
Okay.
Yeah.
So I think, looking at the frequency of tiles is pretty straightforward. I can just make a frequency map of it. So going to words, it's also pretty straightforward if, a letter is in tiles. Let me write some of this down.
Sure.
So let's say make frequency map of tiles. And then, so for each letter in my word then, if it's in my available tiles, then just subtract that and add whatever the tile's value is to my score. And otherwise, I'm going to need an underscore. So let's say there's a case where I do have underscores remaining and I don't. And actually the not remaining is easier. I'll just return 0.
You're done.
Right.
Yeah.
But if I do have underscores left, then I'll just subtract 1 from the underscore and move on. I guess that's it, huh?
Yeah, I like it. I'm going to give you one thing. because this is an interview, and I don't want you to have to do busy work. I'll give you.
Nice.
You don't have to type that.
Actually, what's really nice though, the way you put it on line 6, I could have just copied and pasted this into brackets.
You still have to add the quotes.
Oh,
I formatted it that way for easy reading, but yeah, that's not how we should spend time in the interview.
right.
I was very thankful when you said you do this in JavaScript and not Python, because I don't have the Python version handy.
So if I do something like this method, I can actually try to think about that time space complexity real quick.
Sure.
So for time, first, let's say tiles is n, like the length of it, and word length is n. And so first we make a frequency map of the tiles. So we do an of(n) operation, and then we'll go through every single letter of each word. So that's n.
Well, it's only one word.
Oh, right.
Yeah.
Yeah. Okay. We go over every single letter of that one word. So this is actually n plus n. So we iterate over the word, we iterate over the tiles.
Yeah.
And for our space, we're actually just keeping track of the tiles, essentially.
Right.
So we can just say this is O(n).
Yeah. Yep.
Okay.
I agree.
So let's call this function create score word.
Score word. Sounds good.
So we're given a word in tiles. And so something we're going to be incrementing along the way is counts. So let's keep track of that. Back in my pseudocode.
What is the count going to be again?
I guess a score. Let me just call it a score.
Okay. So that'll be your accumulator variable where you'll total up the score. Yeah. Okay. I'm with you.
So whenever I make a frequency map, I like to kind of abstract it outside. I think it just makes it cleaner. So let's make a frequency map class. So given, it's a string, any iterable. So for each letter, let's just put it in our map object or class, and then increment it by 1. So we'll say, it's kind of fancy syntax. It just means if it's undefined, if it's knowledge, then we'll initialize it to 0. And then we'll just add 1 to it.
Okay.
So we'll say, I don't know, tile map. I think that's an appropriate name.
Tile map, tile counts. Yeah, I like it.
So it's just a new frequency map of tiles. Okay. Looking through my pseudocode, so we have the frequency map. So now we go through word, and then we'll just do our iteration logic. So for const, right. So for each letter, let's see.
I always have to think so hard about versus in.
I made enough mistakes that I rarely make a mistake anymore because it was very painful, like the 20 times
I'm still at that painful stage. So.
Oh no. So if map has this letter, actually, let me just make this explicit. Yeah. So if it's in our map and its value is greater than 0, that means we have tiles remaining for it. So if that's, let's see, subtract tile and add it to score. So we'll just say tile map letter minus and score plus equals letter values of letter. Letter spirit, yeah. Okay, so otherwise, if there are underscores remaining, we can subtract that and move on. And otherwise, we'll return 0. Okay. So else, I guess we can just write it like this. Else if same thing.
Wait, are you switching to Python on me?
No. Oh, yeah, I am. I remember the last time I've done that. That's weird. Okay, so if this is in tile map, then we'll just subtract 1.
Yeah, we've now consumed an underscore.
And otherwise,
yeah, nothing to add to score.
We'll just return 0. And over here, we can return score. So just doing a quick run through, I basically just followed my pseudocode, but we're keeping track of score. Okay, made a frequency map of the tiles. Going through each letter. If it's in our map, then we'll just subtract 1 from our map and add the score. Mm-hmm. Otherwise, we need to check if there's an underscore we can use. If so, just subtract it. And if there's no underscore we can use, then the word is not constructible, so we'll return 0.
Yeah, we didn't have a letter, we didn't have an underscore. No luck.
Okay.
Yeah.
So I can try to start testing this out.
Yeah, let's run a few tests.
So let's see. You provided me with 2. I think those are a nice setting point.
Yeah, we'll start there.
And Tomko. And the expected value here is, I think, 5. Yeah. So if we have cats again, and this time for our tiles, we have Noah underscore. And it is. So thinking about some cases, some edge cases, so let's think of one where we just cannot construct a word.
Sure.
So I'm just going to take out this underscore.
Yep.
0. Let's see, maybe one more that's kind of interesting. I'd say this one's just a happy case. This one we use an underscore. This one we can't even construct the word. I don't know, maybe one where we're using only underscores.
Cool.
Okay, let's give this a run.
Yeah.
Oh, nice. Looks like it works.
Yeah, I like it.
Well, because usually I have bugs, so first try.
Yeah, well, we caught the whole Python versus JavaScript thing.
Okay, yeah,
yeah, no, of course. Yeah, but that wasn't a logic bug. You knew exactly what you were doing there. And that, this is what happens, in these modern systems where we're all looking at a bunch of different languages every day, right? Like that's a normal kind of mistake. So yeah, cool, awesome. All right, let's jump on to the next part of this.
Okay,
excellent. Okay, I'm gonna I'll just paste this at the bottom now. All right, there's.
Okay, so now instead of one word, we have multiple words. And a set of tiles. So is this a tile is still a string?
A tile, yeah, set of tiles is still a string. Yeah.
Okay, great. I'm just writing this down for me.
Yeah, no, of course.
Okay. So out of those words, what's the high score that can be achieved and with what word? Okay. So the not innovative thought process is to literally just try every word. Mm-hmm. And we'll just keep track of the, sorry?
And look for the max.
Pretty much.
Yeah.
So let's say go through every word. And yeah, I might not find a better solution than this, but just to write it down.
Sure.
So to do something like this, it would be essentially the time complexity of the last one, except this time. So, okay, so let's say a word, like just the longest word is, and let's say tiles is K, and words, like the length of it is N.
Okay. I'm going to put these on 3 different lines to make it easier to read, but
thanks.
Yes, I'm with you. Okay.
So doing something like that, the time would be what we did before, except we're just doing it for every single word now. So it's actually N times the last time complexity, which was N plus, oops. So now it's N times N plus K. And for space, it doesn't look like we'd have to keep track of any other data structures at this point, because we could just have, we just have one variable for the longest word, and that's it actually. Well, no, and the score, sorry. So this word and score, so it's constant. So constant space plus what was last time. So last time was O of M, so now it's just OK.
Sure.
So to think real quick though, is there a better way than going through every single word? I think I'd have to go through every single word regardless, but I wonder if I don't have to do the same operation in every one. Maybe I'm not really sure yet. But if I just have
but I like that you're thinking, throwing some ideas out there and then trying to pick holes in them.
I don't know. Let's say we've okay, so we can't make dog, but at this point, I'm really just trying to see if I can, skip logic on some. So for could I know if I saw dogs that it's not valid because dog was invalid?
Oh, I see what you're saying. Where you're sort of short circuiting in some way.
Yeah. Actually, I don't see how this would improve the time complexity at all. I should probably look for something else. Because even if I could skip some words,
right, you still would have had to process those words in order to have them arranged in a way that you would know to skip them.
Right.
Yeah, Yeah, that's a good observation. So there's a interesting part of this problem, which have you played Scrabble? I mean, a valid answer is no. That's not a part of the higher criteria. Okay. So when you're playing Scrabble, you have a set of tiles in front of you on a tray that only you can see and none of the other players can see, and you're trying to make words. In the game of Scrabble, there is a list. There's an official list of what words are valid, and it's a book. It's a big ass dictionary that serious Scrabble players will all have on their shelf, and really serious Scrabble players will memorize even for the most part. So that list of valid words changes rarely. So
wait, I have cards in my hand, and then there's a list of words.
You have tiles in your hand, and the tiles in your hand is going to change, right? So as you play, you'll use tiles and you'll draw new ones. So you're continually getting a new tray of tiles.
Okay.
But that word list, certainly over the course of a game, is never going to change. Right? I mean, it's literally a book, or now it's a website. But you're definitely not going to change the word set in the middle of a game.
Okay.
Right. So if I play a word and then it's your turn, now that word's not valid anymore because it got removed from the dictionary between my turn and yours. That sounds like a crappy game. So anyway, is there something we can do given that the list of words is effectively going to be static?
It's effectively going to be static. So I have some tiles. This is static. This never changes. Never changes. But so I mean, so my tiles never change either. I'm not seeing the relevancy analogy yet, actually.
No, your tiles do change. Effectively, this becomes a one parameter function. You could make this into a class, for example, where the word list gets passed into the constructor, and then the function only takes the tiles.
Oh, okay. So I can optimize. So I just have to think about like if I can set up the words in some way, then on every subsequent iteration.
This is not a dynamic programming problem. No subsequences.
Okay. So, but so later, I'll just have to keep track of tiles, and I can kind of shorten my logic potentially. So I can set up words in some data structure, and then so let's see, what kind of data structure would. So now I'm thinking if I'm trying to, just optimize for just the tiles and additional, I don't know, function calls, whatever you want to call it.
Mm-hmm.
What data structure would help me? So before, I mean, my issue was I'd have to run through the whole word list. Mm-hmm. So the data structure would hopefully be something that I don't have to do that. I mean, the try keeps running. Sorry?
Oh, yeah. So either you don't have to run through the whole list, because you are arranging it in some way, or you can build it into a data structure that then optimizes your query time.
Let's see. Okay. Okay. So if I'm given some tiles like tmac, how can I rearrange this? So I don't need to know the order of letters in each word.
Pause for a sec. So when you're given the tiles, you probably don't want to rearrange the words at that point. You probably are going to want to pre-process the words and then just have them that way and not rearrange them every time.
Right. So I was just thinking I was trying to kind of think to that by playing with this with just the words here. But for each word, I don't need to know the order of letters. So whatever data structure it is, I just really need to know what letter, like the frequency of letters in it, like what letters in a frequency probably. And that would tell me if I can make different tiles or not.
Mm-hmm.
Maybe one thing that could be relevant is the, max possible score associated with a word.
Oh, interesting. Okay, so how would you use that?
Well, so if I know the max possible score of a word,
like assuming you had the tiles to make it, like what would be the score?
Right. Okay. Right, possible. Okay, what would I do with it? Well, if I knew all of them could be made, then obviously I'd just take the best one. But then, the issue is which one of them can be made.
Right.
Or some of them can be made partly only. Well, okay, it can be made either, but is it going to be made with all the letters or just with underscores, for example?
Right. What's the maximum possible score if you had all the letters? And then what's the score you can make given the tiles you have?
Right.
Yeah. And of course, so these are two interesting things we can compute. And when would we want to compute each of them in our process? Like we've got a pre-processing step where we're going to do something with all the words, all the valid words. And then we have our final, hey, what's the best I can do with these tiles right now?
Well, this is something we don't need tiles for. So we could definitely put this in pre-processing. For the actual max tile, so we actually do need tiles for this.
Right.
So if we're to try to play with this, I'm just thinking if we took any word at random and computed the actual max score of it, we could eliminate from processing all the other words that were either the same score or lower.
Okay. Well, that sounds like something to me, right? Like how are we arranging the words? If we follow the process you just described, what does that end up with? How does that arrange our words in our list?
If I want to, put max scores with them, a good option would just be put the words as keys in an object, and then one of the properties is max score maybe.
I see. So you'll pre-compute the max scores so that they're just readily available as you walk through your list.
Right. So let's say in the constructor function, I'm kind of just thinking out loud.
Sure.
Cat, dog, and dogs. I don't know the actual scores for them. Let's say for cat, it's 5.
Yeah, cat we know is 5. Let's see. DOG2, D4. I think dog is also 5.
Okay.
And dogs with a plural is 6.
I could just store it in an object like this, but I'm just thinking. So if I have tiles now, let's say I don't know. I'm still tempted to still play with the array, but I probably don't have to. Let's just not. Let's just pick a random word from our map, because they're in our map anyway. So we'll pick cats, and we'll compute for cat what's the actual max score, and let's say we can only get. Actually, let's say we pick dogs first, and let's say we could get 6. So pick dogs, 6 possible. Then what we can intuitively, what we know we can do is cut these from our processing. Because
but what if we could only make dogs using 2 underscores? What if 6 is possible, but given our tiles, we can't actually get there.
So by possible, I meant like we actually didn't have underscores.
Okay, I follow you.
Right. I guess like 6 available. I don't know.
Sure. Okay.
Then we know we could cut these from.
You don't have to consider them, but then how do we arrange things such that we know we can not process those?
I'm tempted to think of like a max heap, because if you pull dogs first from the heap, and you could get 6, then the next biggest thing is now 5. You can just
like you pull it out, you pull something out, you try it, it either works or it doesn't. Yeah. Okay. Yeah. So if you do that, what is the order that you're going to be considering each word?
You mean like the first word I take and so on?
Yeah, like you've got 10,000 words in your heap, right? What's the order? Which one do you pick up first? What's the next one you pick up? Like, what's that ordering?
In a max heap, I'll take literally the one with the most possible score.
With the most possible score, yeah. So what you're effectively doing then is sorting them, aren't you?
I guess so. Yeah, I am.
Yeah, you're sorting them by the inverted sort, like max first, by possible score.
Okay. But that sounds so I don't need a heap. I could just sort them like that. Even if I had this.
Right.
But so assuming that,
you could use heap sort.
Yeah.
That's effectively what you're doing, right?
Yeah, I guess so. Or, just the built-in JavaScript method.
Yeah.
Okay, so let's say I have a sorted array then, dogs. I'm not really sure I'm adding new information at this point to my method. But
No, you're not adding information. You're clarifying your thoughts.
I see. Okay, clarifying. Yeah. So I could pick the one with the most potential first. Whatever that potential is. So if I put this in an array, I'm just not really. I mean, I guess I could put these in tuples. So let's say dogs and 6.
Yeah.
And so basically, like if I find that I can get 6 at some point, and then the next one is 5, I can just stop there.
Yeah. Well, I mean, if you can make the full value,
right.
You can kind of stop there, right? Because everything after that is going to be at most the same value because it's sorted.
Right.
Right. If you try to make dogs, but you got 5, well, you might move on because the next word might have a max value of 6 also, but maybe you can make that one.
Okay. So, okay, I see. So let's play with that case real quick. So the one I just wrote down is if we actually did just find 6 because we actually said it was possible, then we could skip. However, let's say we said we could make dogs, but we only got 4 for this. I don't know. I guess we can also have like a max score so far. Then we say something like 4.
Yeah.
Then we'd have to consider this.
Right.
And to the end, basically. Exactly.
Until you find a place where your potential falls off.
Interesting. So I feel like what's kind of interesting about this is I think the time complexity is actually exactly the same as on line 83. However, but in a real data set, I'm sure it's more applicable.
Right. Yeah. So because you're minimizing how much you'll have to go through.
Right. So to kind of outline the structure for this class we can make, in our constructor, we can basically, we can make a map, I guess, or actually, we can just put them in a new array like tuples, like how I said.
Sure.
So puts words in new array as tuples, where the first thing is word and the second thing is max possible score.
Okay. Yep.
Then sorts by max in descending order. Then for our let's see, highest
max
score.
Max possible score, highest score. Yeah, sounds good.
So for that method, so we'll start looking from the first word, from the first word, just from left to right, basically.
Right. Yeah, because we've sorted them already, so now we can. Mm-hmm.
Check each highest. Before I said possible score, so now I can say like actual score, I guess, of word. And then I think I can copy and paste some stuff. Let's see, where is it? Oh, is this all I wrote? I guess it is.
Yeah.
So there we go. So rates. Skip, and otherwise just keep going to the end. Yeah. So I don't need to do another. I think I have enough pseudocode. I can start running it out. Sure. That's okay.
Yeah. Sounds good.
So let's just, can I just call the solution? Is that okay?
Sure.
I mean, I know it's kind of lazy. Okay, so for a constructor, let's take in the words. So we'll have a new array. I don't know. It's about doubles for now. And then, so...
is this going to be a local array or is this going to be a class array, a class field?
Oh, yeah, good point, because I'm going to refer to it later. So actually, let me define that up here. Let's say it's called word max possible scores. Okay, that makes sense. So do you write in JavaScript, by the way?
What's that?
Do you write in JavaScript, by the way?
Yeah.
Oh, okay, never mind then. I was just going to say this is private syntax, but if you write, never mind. Okay, so for each word, we're going to put it in there as a tuple. And so to do that, let's see, I already wrote a function for this.
Well, sort of, but it takes tiles.
Right.
So we need to let's assume that function exists. We can write it later if we need to.
Okay.
Yeah.
So let's make a variable that's just local to this block.
Sure.
And we'll just score up the word, and then we'll put it as a tuple in max possible scores.
Okay.
So for each word, oh wait, oops, sorry, score should be in here. Okay. So now we want to score up a word. So for each letter in it, say score plus equals, what was it called? Letter values.
Letter values, yeah.
Okay. And then since we're done with this, we'll say just max possible scores, push new tuple of the word, and then the score.
Yep.
So then we just want to sort it, and then we'll just get out of here.
Yeah.
Wait, let me say something. Oh, it's a B1. So okay, at this point it's sorted. So now we can have our other method. Actually, let's call this not possible score. I mean, wait, what did I call my last one? Score word. Okay, yeah, max possible score makes sense. I mean, I think naming is unironically one of the hardest things to do in an interview sometimes.
Wait, in an interview? No, it's just hard all the time.
Okay, yeah, it's just hard.
There's this whole joke about that. There's only two hard problems in computer science: naming things and cache invalidation.
Cache invalidation. Okay. All right, let me look at my pseudocode real quick. Okay, so we'll look at each word, and we'll find the highest score of each word. We've written a function for that called score word. Okay, really relying on my pseudocode for this. Okay,
yeah, that's
check each.
What is that? Naming things. Wait, is that line 138? Is that a word or is that a tuple?
Oh.
Yeah. What were we just talking about?
Okay. Yeah, max possible score. Okay.
Yeah.
So okay, and then let's look at the max score we've achieved so far. We can actually make it 0 because nothing gets lower than 0.
Yeah.
Okay, so for each thing, we check the highest score, and then we can update our variable with that. I see. And if our current max score is higher than this thing, we'll just break. So if max score is higher than max possible score here, then let's just get out of here.
Yeah.
And otherwise, we'll find the actual score of this and sum it up. Or, compare it with our max. Mm-hmm. So okay, score word. I just have to keep looking back at what I named it.
Yeah, no, it's okay.
So it's the max of itself. And the actual possible value we can get. It might, I don't know, it might be cleaner if I put this in another variable. So const actual.
Sure. We also have to pass the tiles, right? Line 145.
Oh, yes, good point. Okay. So over here, I'll just say actual score.
Yeah.
And then at the end, we can just return max score.
Yeah.
I think I would do it.
How would we want to modify this to return both the word and the score?
Oh yeah, I did forget to do that.
Play this word for this score.
Yeah. So it's just a slight modification.
Yeah.
But so basically, whenever the max score is here, so I won't do this. If max, or sorry, actual score is higher than max score, then I want to update both the max score and the max word.
Yeah.
Right. Okay, we're returning the word, max word. And by default, because I mean, okay, if every single word had an actual possible score of 0, then this would be, maybe I can just default this to tiles1, or the first word. Is that okay? Because then it would have 0, and then everything else would have 0. Or I can also make a slight greater than or equal. This will also work. So I'm just thinking, like, if every single word in the words array has an actual value of 0, then if this were like actual score would never be greater than 0. So
but also, what if you can make no words?
Wait, if you were passing an array with no words?
No. What if your tile set can make no words?
That's a good question. What should we? If we have no words, something reasonable to return would be. I'm not sure.
You have a tile full of Z's, or a tile set full of Z's. Like there are no valid English words. We need to return something. We can just pick something.
Null, maybe.
Yeah, maybe an empty string for max word and a 0. Like you got nothing.
Okay.
We can pick something here, and that's okay.
But so let me think. So and on the other hand, if every single word were possible, but it was just a bunch of underscores or tiles, then we would just return any arbitrary word, right?
Yeah.
Okay.
Yeah.
So let me just write that down real quick, because actually I think I'll have to think just a bit about how to accommodate both of those. If all words possible with score 0, return any word, and if no words.
Yeah.
Return, I guess, looks like you changed this to a tuple, so we can make null. And should we put 0, or we can just choose null as well?
I think, I think 0, like you can't make you can not do anything to increase your score. This turn, you will do nothing. Yeah, I think 0 makes sense there. We're actually exactly on time. So this we got to a really good spot. Let's pause there. Very cool. Questions, comments for me?
No, I thought it was really cool how you didn't really care that much about syntax errors. I mean, you were kind of helping me out with that, and you were pretty involved in the thought process. It felt like we're kind of collaborating on a problem, even though obviously you know it.
Yeah, right. I actually have one question for you that I had. This, to be clear, this wouldn't have changed the outcome from a higher no higher perspective, but you said something that I was really hoping you would follow up on. So you threw out the idea, or you brought up the idea of using a try, and then you didn't go down that path. Why did you reject that idea? You considered it, and then you very quickly moved on. What?
Yeah, it wasn't so much as rejecting it, so much as I had never begun to thought of it. I literally just had the intuition of what if we had tried to use a try. But since you had quickly given me a hint of going a different direction, I felt that was a lot more safe for me.
Okay. Cool. Good. I mean, that's part of my strategy with hinting too, is that I want to see how you respond when you're, in a collaborative environment, right? Like, so that's actually part of the part of the design of the interview.
I see.
Yeah, that's not an indication that maybe you're not doing well. It's an indication of like, oh, I'm trying to learn, how do you do in a collaborative environment where we're both bouncing ideas off of one another?
Yeah, I think so. In a real environment, like if we were both working on a problem, like none of us knew the answer, I would still consider using a try. This is more like collaborating where I guess like you're more senior than me, so like I trust that you have a better idea that the direction. The
Oh no! Wrong! Because personally, I'm wrong a lot.
Yeah.
Right. I may have been at this game longer than you, but that doesn't mean I don't have bad ideas sometimes.
Okay.
Maybe I should have thrown out a red herring that I knew was a bad idea.
Do you ever do that?
Yeah.
Oh wow. Because I was just thinking I was just thinking in an interview, like, would I really want to be like, I don't know if I like your hints. Like that sounds bad.
Well, you don't say it like that. You say it like, hey, that's an interesting idea, but I'm not sure it works because of this, this, and this. Like, oh, if we did that, we'd end up having to solve this other problem over here. That's maybe not leading us in the right path towards a simpler solution. Like you can always, like make a non-judgmental statement about an idea. And like that, I mean, that's how engineering collaboration works. Like I throw out an idea, you throw out an idea. We try to like judge the ideas, not like, hey, Daniel, you're dumb. That was a bad idea. I mean, I may be dumb, but that's not how the conversation.
No. I'll keep that in mind though. I've never considered actually like coaching back even like politely with a hint. That's interesting.
Yeah, no, it's definitely something like, to me, that's part of like being an engineer on a team is having these conversations and having these like debates, when we're going through this ideating process to solve a new problem. In this case, I know the problem pretty well. But in a real setting, when I haven't solved the problem before, my idea might be as good as yours, or maybe not as good as yours, right? So thinking critically about everything that comes in, I think is a good thing.
Oh, sorry. Can I stop sharing my screen, by the way?
Oh, yeah. You can stop sharing.
Cool.
Yeah.
Okay, nice. Now I can see your face. I was like just staring at my screen the whole time because I didn't want to like have an infinite loop.
Oh, right. Yeah, we tend to avoid infinite loops in interviews, so that's a good thing. Awesome. Any other comments, questions? I mean, I think this went really well. The way this problem is structured with the two parts, it's intended to be a first part that goes relatively smoothly and easily, and it did. Like you very quickly latched on to the idea of building the map of tiles and then decrementing as you accumulate the score. I really liked how you separated the problem-solving part of the process from the actual coding part. It made the coding go really, really smoothly and easily. And you were always double-checking the code you were writing against the comments you had written previously with the idea. So it reduced the kinds of logic errors. Like we still had that silly syntax error of like and versus ampersand, right? But those things the system will tell you about, the runtime will tell you like, hey, there's a syntax error there, right? You'll get this immediate feedback, even if it wasn't from me, right? Like that's why I actually pointed that out, was like, that was the kind of error that you're going to get rapid feedback about. I'd rather just short circuit it even a little bit more and say, hey, I'll play compiler, right?
That's really, that's really cool.
But you weren't making logic errors because you had very cleanly and clearly defined exactly what your logic was going to be ahead of time, not even in pseudocode, in plain English. And so then the coding part went really smoothly. And then the second part gets a lot more interesting because there's these trade-offs around like how do you structure the data. There's many data structures you can consider. This was actually the first time I've run this problem where somebody got to the second question and actually hadn't played Scrabble before. Well, yeah, which is fine, right? Like again, that can't be part of the hire no hire criteria here, right? So if you've played Scrabble, it's a little bit more clear at the outset that the word list isn't going to change. So I needed to like provide that part, that context, but I don't care because I can't expect everyone to actually know that that's how the game works, or even that this is part of a game. Right. And then once we sort of get to that point of like, okay, the word list isn't going to change. Now that starts to open up some possibilities for like how we approach the problem. That all went really smoothly.
On that second part, I thought there were two really interesting things. Like one is that I was taking notes on how Scrabble was played, like while you were telling me. And the other one was when I talked about my brute force, so I made the time complexity for everything, and I wasn't even considering about the other thing because I was like, time complexity doesn't even improve. What's the point? What's the point?
Yeah, exactly. Like you're making engineering trade-offs. Like that's awesome, right? Like, hey, actually, this is not bad. This isn't a quadratic algorithm, for example, right? Like it was basically linear in the size of the input. Like, yes, you're doing some multiplication there, but at the end of the day, the sum total of the input, the real N in our complexity analysis is always the total size of the input. So like your complexity was well bounded already.
It's also interesting because this is a class of problems that tests that kind of like business logic then. Because I mean, I don't know, maybe you would, but like, even though the time complexity was the same, you would agree like the thing we did later on was more efficient, even though the time complexity was the same.
It's a little bit more efficient. It's not more efficient from a complexity analysis perspective, but it's always a good idea to organize data in a way that allows you to easily answer the questions at hand, right? Even if it's not making a dramatic difference in the theoretical, average case or worst case runtime complexity, you're still making your task easier. And the fact that we were able to make the task easier with not a lot of code, and in fact, just calling a built-in sort function, and being intentional about the direction we're sorting and what our sorting criteria, is going to be. Like in this case, it's not a lexicographical sort of the words, it's a descending sort based on the total max score. Like, so we made an explicit decision there that made the rest of the process easier. So it's not an optimization per se, but it's a simplification.
I think that's definitely a class of problems that doing a lot of leak code doesn't necessarily, like, I'm not inclined to think about, because I'm literally only thinking about time complexity, but yes, right. That's interesting.
Well, and I'm glad you mentioned that, because I think that's one of the shortcomings with, number one, practicing leak code problems, because they don't actually prepare you to do good engineering. Right? They prepare you for questions that people tend to ask in interviews, but they don't prepare you for making engineering trade-offs. And and unfortunately, people do actually use that style of question in a lot of interviews, and I think it's questionable the kind of signal that they're getting in order to hire somebody as an engineer, right? Because like this kind of problem comes up all the time. You've got a bunch of data. You need to munge it around and organize it in a way such that you can answer a question and answer, or a class of questions. Like that's like just like you said it. It's like business logic, right? And that's, as in most product engineering roles, like that's most of the work is this kind of thing. So to me, this kind of question is highly applicable to the interview process, right? Because it shows me what you're going to do on a problem, on a class of problems that's likely to come up every day on the job. So I like this kind of interview question, but yeah, leak code does not prepare you for it.
All right, it is raining heavily. The storm just flew in just as I was about to record this final outro, so you might hear it in the background, but let me know what you thought. If you watched this on YouTube, let me know what you thought in the comments. And again, seriously, thanks so much for sponsoring this video formation. Definitely check them out, but I hope this helps. Good luck.
Just see see.